Okay, this is the electronic controller board for the automation of the QRC motor control wind-up. What we see here is the board, and we have few connectors here, and these connectors you just short out the inputs, and we have a shortened switch input. The first one is for the lower sensor, and we go for the high sensor. Then I have a second sensor which I call the high 2 sensor in case the first one breaks down, or it could be for temperature control to shut down. And then we have an emergency stop. Here we have two outputs that control a relay, 12-volt relay, for turning the motor on or off. And the two of them are, one is for the motor and the other one can be for a reverse or for a clutch. And this connector, we plug in 24 volts AC, 12 volts AC, and this could set the circuit to close the relay at the zero crossing of the 110, 120 volts AC. And if we close it at zero crossing, it means there's no voltage across the contacts, thus elongating the life of the relay. Right now I'm using an internal timer that generates the clock for the state machine, which is the brains of this board in its first version. The second version is to plug in a microprocessor with a connector below the board. But for now, this is just what we call the PAL version, programmable array logic. And we have some LEDs here. These LEDs dictate what state the board is in, and is used for debugging. State 0 is the state it comes up in, and if it doesn't, it'll go to state 0, and waiting for input is state 1, and these are 4 LEDs with a binary state, and we will see it go to state 0 first, which is all LEDs off like now, and then it'll go to state 1. Here goes the power. State 1. So it's waiting for a shortened input on the low sensor. It's just sitting there, and I will just short it out with this connector here. Then we'll see the relay turn on with a little switch on it. And we're in state 1 because the LED is on. Here we go. And the relay is on. It's switched off. The lights are off because this is the waiting period of a human being having a rest. And it will also give the pendulum a little more momentum for when the friction goes high, and there's less momentum to sustain the pendulum during the wind-up period. Right now there's not a problem because the clock has been lubricated. So this cycle continues over and over until we get a high sensor. Let's go through one more cycle again. It's resting, and the relay will turn on and off throughout the wind-up period. This is the wind-up period. This would extend the wind-up time from maybe 5 minutes to 10-15 minutes. But when we have to wind up every 9 days, that's not much of a difference or problem. So let's now put the high sensor in, and it'll immediately turn on. But let's wait till it turns on. It's on, and then I'll put the high sensor in, and it goes off. I could leave it in, it's still off, and it stays off. Now for the chimes, when it's chiming, there's no energy to the chiming mechanism. Therefore, if we start to wind up during a chime, the chime will be interrupted. And I'm not sure what the effect is other than it will be interrupted. Typically, a human being will not wind up during a chime. He will wait until the chimes are gone and continue winding up. Because if he does do it, he'll quickly learn that the chimes stop. I had built in a circuit for an amplifier, really to amplify maybe a microphone on a camera there, because I thought a camera watching the mechanism for failure remotely would be a very good idea over the internet. So I built in a circuit here which is an amplifier input and an output. input on the left, output on the right. And it's also linked as a sensor input with a diode such that we can rectify noise, high energy noise, like a microphone right next to the bell, and we could process this. But I had planned it for the microprocessor version, not this version. Hopefully, after recognizing there is a problem during a chime of winding up, I could redirect this microphone. And the circuit is not built in yet, it's still in assembly, debugging. And I have the microphone here, which hopefully I can do as soon as I can. This ends the demo, but let me trigger another cycle again to just end the demo and watch the relay turns on. Relay goes off because that's the way I have the logic. And this ends the demo after it turns on one more time. I just want to talk a little more about the microphone, which I really didn't cover properly. The idea of the microphone is to hear and sense when there's a chime. And if there's a chime, it will delay the wind up. Therefore, the winding up does not stop the chiming with this microphone sensor. The other feature of this board is that there are connectors for an external timer. This external timer is designed to disable the circuit if the high sensors fail. Upon a low sensor, the timer is triggered for, let's say, 4.5 minutes, and if the high sensor is not sensed during that 4.5 minutes, the timer would shut down the circuit. The emergency stop is a stop that is supposed to disable the circuit, and the only way to have the circuit continue is to power cycle it, or if there is a failure, deal with the failure, fix it, and then power cycle the whole board. But after an emergency stop, there is no recovery, it just stops.